Okay, this is our last type of optimization problem. This is the one where pictures don't help, but making a table does. Moreover, it's pretty much the only way you can actually show work, so it's not a bad thing to do. So here's an example. We run a small furniture business. We sign a deal with a customer to deliver up to 400 chairs, the exact number to be determined by the customer later. The price will be $90 per chair up to 300 chairs, and above 300, the price will start being reduced by 25 cents per chair on the whole order for every additional chair over 300 ordered. What are the largest and smallest revenues your company can make under this deal? Well, I'm not going to worry too much about the smallest, because if they buy 0 chairs, we'll make 0 revenue, right? And moreover, until I start getting a discount, they're just going to make more money per chair. So up till 300, it's very easy to figure out. It's after 300 that it starts to get a little gnarly, and what I want to do is start making a table, see if I can't organize to see what's going on. So what we're going to do is we're going to go over to my little whiteboard, hopefully, and see if we can't start crawling our way through this. So here we go. All right, here we are. Now, you see I have let x be the number of chairs over 300. I could let x be the number of chairs. I think that's actually a little bit harder to do it. What I'm going to do is just start making a column and just see if I can't get, this is going to be price per chair. And then I want a bigger one that says revenue. Now, once we get a formula, we won't need the table anymore, but here we go, right? If we get 0 chairs over 300, well, the number of chairs is 300, and we're told that the price per chair is $90, and so the revenue is just going to be 90 times 300. No discount yet. Now, if we order 1 more chair over 300, they've promised us that for the entire order, they're going to subtract a quarter. So it's going to go like that. And what I want to do is now multiply the price by the number, right? Well, the price is just the 90 minus the 0.25 times the number of chairs, which is now 300 plus 1. Now, don't simplify until you see a pattern. So here we go. If I have 2 chairs over, they promise to subtract another quarter. So what I'm going to do, I'm going to try really hard not to simplify, because this way I actually see both quarters represented. Now, what's the revenue going to be? Well, it's going to be 90 minus 2 times 0.25 times 300 plus 2. And I think you can already see a pattern here, yes? If I order 3 chairs, what's going to happen? Well, that 2 is going to turn into a 3. That 2 is going to turn into a 3. That 2 is going to turn into a 3. So what I'm going to do is just put a little x here, and I see the price is going to be 90 minus 0.25x, like that. And the revenue is going to be the price per chair, which is going to be 90 minus 0.25x times the number of chairs, which is just going to be 300 plus x, like that. And that's going to be our formula. So what I'm going to do up here is I'm just going to erase this much. I'm going to push my formula up to the top and worry about what we can do. So I'm going to write down that the revenue, as what we have in the bottom, is 90 minus 0.25x, like that, times the number of chairs, which is 300, plus x. So we have a formula, which is great. The one thing you should always do after you find a formula is hope to actually find a closed interval. Now, what could a closed interval mean? It means, is there a smallest x that you're worrying about and a largest x that you're worried about? Well, we're not worrying at the moment about selling less than 300 chairs. That's a completely understandable part of the problem. We'll try to incorporate that at the very end. But meanwhile, we at least get that 0 is less than or equal to x. Now, but they said they're not going to rent more than 400 chairs. Well, that's just going to put a 100 here. And we have a closed interval. Now, what does that mean? That means in terms of finishing the problem, we get to make a table instead of a sign chart, which is just awesome. Now, I want to take the derivative of this. I really don't like that minus 0.25 there, so I'm going to actually just pull it out. So this is just going to be, I'm going to pull out what I want here. How about minus 0.25? Now I'm just pulling the 0.25 out of this thing here. So this is the minus 0.25x is going to turn into x. The 90 is going to turn into 360. So this is our function. Now I'm going to write this as x plus 300. It just feels more comfortable this way. Not the way I came up with it. Now I want to take the derivative, and I could use the product rule, but at the moment I think I'm just going to multiply it out. Of course I'm not going to put the minus 0.25 back in. That's just a coefficient. I'm going to FOIL, so I get x squared, like that. Let's see, I'm going to get what? I'm going to get plus 300 minus 360. Well, that's just minus 60x. That's a very easy thing to take a derivative of, so I'm happy I did that. 360 times 300 is, let's see, I'm going to get minus 108, and then 3 zeros. Now, it's a pretty big number, but when I take the derivative of it, it's going to go away anyways, so I'm not so unhappy with that. Taking the derivative now is really easy. So I say the derivative, the minus 0.25 is a coefficient, it goes along for the ride. And what I'm going to get is 2x minus 60 plus 0. Not so bad. Now I'm supposed to look for critical points. Critical points are where the derivative is 0 or where it's undefined. Now this is a line. It's always defined. Now out of 30 points, by the way, saying it's always defined is going to be worth a point. And it'll be in the habit because now and then you're going to see a derivative that's not defined at places. We've already seen some of those. Meanwhile, since there are no kinds of critical points like this, I find the other kinds of critical points by setting x equal to 0, and I get x equals 30, which is not so bad. So there's only one critical point. Now, since we have a closed interval, we get to finish this by making a table. Now, what do we mean by a table? What we have is a closed interval. We know on a closed interval, the only places there can be a maximum or minimum are places where there are critical points or the endpoints. So what we have here is just 0 is an endpoint, 100 is an endpoint, and 30 is an endpoint. And what we want to do is plug back into the function. I think I like this one right here, although I'm really going to use my calculator for this. I'm just going to put r of x. Now when I plug 0 in, according to my calculator, we get 27,000. I don't mind having the calculator do this because they're just doing arithmetic. When we do 100 chairs, we actually make less. Right? We're giving too much of a discount, so we're actually making less money. If we sell 330 chairs or rent 330 chairs, according to my calculator, we get $27,225. So the maximum value happens here. We only want to sell them 330 chairs or rent them 330 chairs. The min, well, the minimum I can possibly make between renting 300 chairs and renting 400 chairs is 26,000. But remember, they didn't have to actually do 300. They could have rented 0. So the minimum number would be $0. And I would be very unhappy with that. Anyways, that's the whole problem.